how traditional networks looks like. So every organization have these things. First is data center. Second is headquarters. Third one is branch sites, or some people also call it remote sites. Right. Now, every organization in this world will have a data center, a headquarter, a branch site, and a remote sites. Yes, Randhi, DMVPN is a solution which is only available on Cisco devices because this is a solution provided by Cisco. Right. Now, every organization will have a data center, headquarter, and a remote site. So, how an organization will look like? Let me give you a WAN perspective of it, right? A WAN perspective. So, let's say this is your data center. Guys, understand it very carefully because these are the building blocks for SD-WAN, right? I'm not saying that you will not be able to do SD-WAN practicals if you don't understand this. No. If you have to clear the picture in your mind, what is SD-WAN, why we require it, these things are very important. Now, let's say guys, this is your data center, right? So in data center, I'm just talking about the WAN perspective and what is data center. So data center is a place where we kept all our servers, right? All your virtual machines are installed on those servers, all your applications, all your database, everything is there in the data center, right? Now understand it like this. Let's say you have a remote site, right? This is remote site or your headquarter, whatever you want to think it. Let's say this is the headquarter. Now these headquarter sites want to communicate with my data center. Yes. So I want to connect them. Now data center will have both types of connectivity. When I'm saying both such types of connectivity, what do you mean by that? It will have internet also and it will have MPLS also. So data center will always have both sort of connectivity, MPLS also and internet also, right? Now let's say there is some headquarter site which want to connect to my data center. So I will provide him a MPLS link, right? Now what will happen? This headquarter site can communicate with my data center with the help of this MPLS, right? And it can access all the services with the help of MPLS. Any doubt in this? No, we are good. So what does the traffic flow? Traffic flow is from my HQ or from my branch site. Traffic will go to MPLS cloud, right? And from MPLS cloud, it will go to my data center. Now, what about the inter-network traffic? Okay, there are two types of traffic: intra-network, which belongs to same organization, and second is internet. Internet means the traffic which want to go out of my organization, right? When I'm saying it want to go out of my organization, what do you mean by that? That traffic can belong to Google, it can belong to Yahoo, it can belong to YouTube, LinkedIn, Facebook, right? And any other thing which is existing on internet, right? Any government website, right? So how we are sending the traffic from my headquarter site to branch office, to MPLS cloud, to my data center. Now this is about the traffic which belongs to intra-network. What about internet traffic? Internet traffic will be forwarded like this: from my headquarter, branch site, to MPLS cloud, then to my data center, and from my data center to internet. So all these things are existing here. So if I have to tell you about the flow number 2, from headquarter site to the data center, from data center to the internet. Now the first question is, why we are not sending traffic directly to the internet from the headquarter site? Headquarter site has this sort of link. MPLS. And from MPLS cloud, you cannot send traffic directly to internet. Right? Now, second question is, Piyush, what we can do is we can purchase an internet link here also, like this, for this office, and we can send it directly to the internet. But I have a question. This is a rule. Before sending traffic to internet, right, what we have to do is we have to pass it through few security devices, right, like from a firewall, right, second from a IPS, right, third, any other thing coming in your mind, guys? So before sending it to the internet, we have to pass it through few security devices like firewall, IPS. Now you are like, Piyush, why? See guys, if I want an internet connection here and I want to send traffic directly to internet, I have to put a firewall on this site, right? So first thing is, okay, let me write it here. First thing is install firewall on the site. Second, manage it. So you require a security engineer also to manage it, right? Third thing, if this internet goes down, still you require the same set of policies on your data center firewall, right? Right. So this particular thing is called distributed security. What we call it? Distributed security. What do you mean by distributed security? Distributed security means we have remote sites. Every remote site have its own firewall and we have a set of policies defined there, right? But nowadays companies are not nowadays, I'm talking about 10 years back. 10 years back, companies were moving from this distributed approach to a centralized approach. Why? The reason is simple. First of all, they want to save the cost. They don't want a firewall here. First thing. So they don't have to install a firewall on site. So if there is no firewall, there is no management, right? Second, what they will do if they have an internet link also, right? If they have an internet link also. You can ask me a question, Piyush, what will happen if this MPLS goes down? What will be the backup? Yes, we can have an internet link and we can build a VPN from this site to my data center, right? So VPN will act as a backup, right? And what is the centralized approach? That whenever any site want to reach internet, instead of sending traffic to my data center, instead of sending traffic directly to internet, let me send it to my data center, right? So guys, if I have to represent this particular thing to you, it should be like this. Can you see here? So this is any of my remote site. This is my data center. Now this is WAN. WAN means it can be any WAN, it can be MPLS, it can be internet. In all the cases, traffic is going from my remote site to the data center, then to the internet. Now you will ask me, Piyush, what are all these applications? These are Dropbox, drives, Google Drives, right? Microsoft Word, Microsoft Excel, right? PowerPoint, Google Plus and SAP application. So all traffic is backhauling to my data center, right? And what is the advantage here of having this design? The advantage is centralized security will be there, right? We will be able to save the cost. Why we will be able to save the cost? Because we don't need firewalls on all the sites. We just require firewalls on my data center from where we are exiting and entering all the internet based traffic, right? So this sort of design we were using in my WAN, right? Nowadays also more than 50% companies are using this design. More than 50% companies. And what is happening because of this? Let me tell you an example of this. Because I work as a network consultant, right? So I come across multiple problems that we have with this design, right? What are that problems? Let's say guys, let's say this is North America. And this is your South America. Right. So let's say you have a data center here in North America, fine, and you have a remote site here in South America, and they are connected. They can be connected by MPLS or they can be connected by VPN, right? But what is the design saying? The design is saying that whenever we want to reach internet, we have to go to the data center. So let's say this is your data center, and this is your remote site, right? Now, whenever any traffic want to go to internet, it will go to the data center. Let's say the users who are sitting in South America remote site want to access a government website. Which website? Government website, right? But traffic can directly flow from this site to the government website server. But how it will flow? It will flow to my data center, and from my data center it will come back to the government website, right? So this is called, guys, inefficient routing. We are adding a lot of latency to the traffic. You will say, Piyush, how we are adding a lot of latency? We are adding a lot of latency. You are sending a traffic from one continent to another continent and hauling it back to the government website, right? Sending it back to the government website. So what we are doing, we are adding latency to the traffic because of our design. And guys, think about this thing. If you are in India, let's say we are in APAC, or we are in Asia, you can think of this as Asia. And let's say I have a company here, right? And its data center is in US. Now try to understand, if you want to open any website, let's say you want to do net banking from your office, right? So how traffic is flowing from your company network to your data center and back to India? Are you able to understand this approach? So what we are doing, we are adding latency to the traffic. That is not correct, right?